Hello to Internet. Welcome to the Supervised Machine Learning tutorial. This is the part 1 of the series. This tutorial is for complete beginner. You don't need to have mathematics background, neither programming skills in order to follow this tutorial. All you need is the motivation. So let's start. Welcome to the Supervised Machine Learning tutorial. In this tutorial, we are going to improve our understanding on machine learning. Previously, we talked about supervised machine learning, and the supervised machine learning is when you have access to the inputs and the corresponding outputs inside your data. There are two types of supervised machine learning. As you can see here, the supervised machine learning is divided in two: the classification and the regression. What is the classification? The classification is the supervised machine learning task. The goal here is to predict the discrete output value that belong to a particular class. As you can see here, we have two classes. This is the case of binary classification. If we have more than two classes, is the case of multi-class classification. This class can be written as 1 for yes and 0 for no. Whereas regression is a supervised machine learning task. The goal here is to predict the continuous output value that is close to the actual value. One example of regression application is the housing price prediction. With the housing price prediction, we have the futures with the labels. The futures might be the number of bedrooms, the size of the house, or the location. Based on these futures, we can predict a price for a new house. For the classification, we can use classification to create application for medical imaging. Here's one example of classification application in medical imaging: the malaria diagnosis application. With the malaria diagnosis application, we can use the blood test images to predict the discrete value that belong to a particular class, such as uninfected or infected. These images or these blood test images has been cleaned and labeled by experts. The goal here, we want to train our model based on this data. Once we are satisfied with our model, we want to predict a new blood test images to a particular class, uninfected or infected. That's how we can use classification application in medical imaging. Another case is classification application in marketing. As you can see here, we have customer data. We have the futures with the corresponding label. As you can see here, the labels are the discrete values. We have the class 0 and the class 1. Each customer has been assigned to a specific class. If the customer bought the item, we assign class 1. If the customer didn't buy the item, we assign class 0. The goal here, we want to train our model based on this data. Once we are satisfied with the model, we want to predict the new unseen data. Given a customer, we want to predict a distinct value that belongs to a class. For example, if the customer is going to buy, we are going to assign the class 1. If the customer is not going to buy, we are going to assign class 0. That's how you can use classification application in marketing. Here's one example of regression application. As you can see, we have the data. In our data, we have the futures with the corresponding labels. As you can see, the labels here are the continuous value. And as you can see, we have more than one features. This is the case of multivariate regression. If you only have one feature, is univariate regression. The goal here, we want to train our model on this data. Once we are satisfied with our model, we can then predict the new unseen data. Given the input, we want to predict a continuous value, which is the wind speed, which is close to the actual value. That's how you can use regression to create application to predict the continuous value.